Okay, example 3.8 comes next and builds upon example 3.7, which was the script we just wrote to compute the nth element of the Fibonacci sequence. And so in 3.8, we're asked to build upon that code to, instead of just reporting the nth element of the Fibonacci sequence, to instead essentially plot the elements of the Fibonacci sequence from 1 all the way up to n. And the example problem is the specific case of 20, but for the purpose of this screencast, we'll just keep our script generalized from the last problem and plot the resulting sequence and return the nth element of the sequence. So let's do it. Give me a second, we'll switch over to MATLAB and we'll get to work. Okay, so here I am now over in MATLAB, and everything is still untouched from when we wrapped up exercise 3.7. So we'll go from here and build everything up. The first thing I'm going to do is I'm going to take this script fibn and I'm going to resave it, and I'm just going to call it fibn2. Okay? So the sole purpose being is I don't want to overwrite that file that I just created that some of you may be looking at as you work through exercise 3.7. Okay, so I'm just going to create a copy that we'll use for the purpose of this exercise. And so basically, we're going to take this and we are going to make things look pretty and beautiful and create a beautiful plot. Okay, so a couple of things that I'll do now that I'm looking at this to clean things up is our script has a precondition of n and a postcondition of answer. But I notice when I run it, I'm going to have variables f1 and f2 that have been created. Previous 1 and previous 2, those burner variables, are also created, as is n, which is my loop index variable. Well, no, n is what's being passed I, my loop index variable. Okay, just as a note, if you wanted to clear those before, at the conclusion of executing your script to make sure they're not inappropriately used, you could do so by just adding a clear command. So you'd add clear, and then you would list the variables separated by a comma that you would like to remove. So I'd like to remove F1, sorry, no comma, clear F1, F2, Fi I could clear, answer we don't want to clear, and I could even kill n, I, previous 1 and previous 2. Okay, and actually I've eliminated previous 1, so it's not in there. Okay, so I could delete F1 and F2, which we use to get the sequence going, Fi, since we're ultimately storing the result to answer, I, my counter variable, and then previous 2, which is this intermediate variable. Okay. So what I'll do is I'll clear this. Let me just clear all variables. Okay. And so if I comment this out for now, and I run fibn2, well, I'll do n is equal to 10, rub fibn2. All right, I get 55 just as before, and then we see that all of these other variables are created. So besides just having n, my precondition, and answer, my postcondition, or ans, at the conclusion of running the script, I have all these extra quantities as well. Okay. So let me go back, clear all my variables, start fresh. So now if I uncomment it, in this version, I run, first I need to do assign 10 to n. Now if I run fibn2, right, I still get 55. And in my workspace now, there's only 2 variables that have been created. And what's happened is I've cleared out all those other variables that were created within the script that I may or may not want. Okay, that might not be important to you. This may not have any effect, but you could think of it as an example of how you might do that if it's of concern to you. Okay, so now let's build this up and let's create a plot. So since I'll be plotting multiple data points, the first thing I'm going to do is I'll execute a hold on. Remember, hold on will bring up my figure window, and we'll also tell MATLAB not to clear the data points or a set each time a new set's plotted. Okay, so I initialize my sequence, and so let's start now by plotting F1 and F2. Okay, plot F1 and F2. So the command is plot. So F1 corresponds to the first element, so it'd be 1 comma F1, and we're told to plot using red circles. So then F2 is my second element. Okay, so my independent variable followed by my dependent variable, or in this case your index, followed by the element, also plotted as a red circle. Then each loop iteration, when we compute Fi, right after we compute Fi, we'll want to plot I comma Fi, again as red circles. Okay, excellent. Okay, in this case, I mean, I could put the plot command after here where I say thinking ahead. Since I'm not overwriting Fi, it would be okay. And so let's change this to computing and plotting. Excellent. So now if I run this, the result should be it'll generate a plot of my Fibonacci sequence, and then also what will be stored to answer will be the nth element of the sequence. Okay, so if I run fibn2, beautiful. All right, so you can answer 55, and I get this nice looking plot. Okay, and let's keep building it up. Okay, so after I exit the for loop, let's make our plot pretty. Okay, so let's add a comment that this is store the nth element to ANS. And then let's add a comment and let's make our plot pretty. Okay, and you got to have some fun with the comments. Okay, so the first thing I might think about is adding x-axis label and y-axis label. So x-axis label is x label. It's a function call, so I have parentheses. The argument's a string. So in this case, the x-axis label is I, where I is just indicating the index. So if I want a y label, okay, in this case the y label is f of I, the ith element. And so here when I write f underscore I, what that'll do is it'll draw I as a subscript of f. If you want to look at formatting and how you can italicize things and things of that nature, have a look at the MATLAB documentation. But for now, we'll write a subscript, which is very good. Okay, maybe I want to add a title, and so my title might be Fibonacci sequence. Okay, what else could I want? Okay, so if I run this just to get a look at the plot again, right? So now I have y-axis, x-axis, title. Legend wouldn't do much for me in terms of changing my y limit or x limit. It doesn't look like that would be much of a big deal either. Okay. So what I'll just do then, just in terms of developing good habits, is besides just making the plot, let's save a copy. So the save fig command will save a file of type FIG, a MATLAB figure file, which will allow us to open it later with MATLAB if we want to build upon it or edit it. Okay, maybe I want to call this Fibonacci sequence. Okay, now fig. And then also it'd be nice to print. Okay, so print to an image format so I can include this, say, in a lab report. And so that's the print command. two strings. First will be the file type, so do D, and then type is PNG, followed by the name, so there's that PNG. Okay. I mean, this is rather basic. If you wanted to, there are ways that you could add the N into the name and things of that nature, but for the purpose of this class, this is beautiful. Cool, so I've updated the code, and so I've only added a little bit to it. So we're going to compute the nth element of the Fibonacci sequence and generate a plot. Okay, that messes up my line wrapping, but that's okay. Okay, so I've added a hold on to open up my figure window, and then also to make sure that MATLAB isn't clearing the figure every time I plot a new data set. I plot the first two elements of the sequence, and then I've just added a single line into the for loop, where after I've computed the ith element of the sequence, I'm going to plot the ith element versus the corresponding index. And then the material I've added at the end is just a matter of making the plot pretty, adding axes labels and a title, and then saving the figure. So if I run it, okay, beautiful. Okay, so there's my plot. So that's figure test, Fibonacci sequence.fig I have. Remember, I just say double click on it. Opens up figure window 1, which I could edit and tweak. And then there's also PNG, where if I right click on it, I can open up outside of MATLAB in my default image viewer, and it looks beautiful. Okay. And then remember, this is generalized, so the problem statement, it says consider n equals 20, so I can assign 20 to n, and then I can rerun this fib_n2, right? And it works just the same. So now n 6,765. Here's my plot. The plot's just a little harder to visualize because it grows so quickly that you can't pick up on the differences down here at small n values. Okay, but another job well done. Keep up the excellent work.